So for the equation ax equals 0, it always has a solution x equals 0, right? When you multiply something by 0 and you get 0, right? So 0 is always a solution, so we call it the trivial solution. A system of linear equations is called what if you can write it as ax equals 0? Yeah, homogeneous, homogeneous, I don't know how to say it. All right, the equation ax equals 0, which is a homogeneous equation, it has a non-trivial solution, meaning a solution where x isn't all zeros, only if the system has at least one free variable. You guys are good readers. So today we're going to learn how to express the general solution to a linear system using parametric vector form. And we're also going to see the relationship between the solution to a non-homogeneous system and its associated homogeneous system. And we're going to practice describing solution sets geometrically. All right, so here's a system of 3 equations with 4 unknowns. On the other side of the equal sign, the right side, those aren't all zeros. So this is a non-homogeneous equation. We're going to write out the associated homogeneous system, okay? Which means just take the right side of the equation and just make it all zeros. That's the associated homogeneous system. So as a matrix equation, so I'm going to put my coefficient matrix here. So a matrix equation is AX equals B, right? An augmented matrix. People often confuse matrix equation with augmented matrix. So matrix equation is A times a vector of unknowns equals another vector. So you start with a coefficient matrix. So my x1 coefficients are 1, 0, 2. My x2 coefficients are 4, 0, 8. And x3 would be -2, 3, -4. And x4, I've got -3, -3, -6. That's my coefficient matrix A. And then my vector of unknowns is going to be x1, x2, x3, x4. And then my vector B, right? I'm writing out the associated homogeneous system, which is just going to be all zeros. How many zeros should I put in this vector over here? 3, because it's representing what goes on the other side of the equal signs. So there should be 3 zeros, 1 for each equation. So just to make sure that you did this all correctly, that you have the correct number of columns in these 2 vectors, it's helpful to sometimes write out the dimensions. So this coefficient matrix is a 3 by 4, 3 rows, 4 columns, which means that my vector of unknowns has to have 4 entries because it's got to match. The inner dimensions have to match. So this is a 4 by 1. So I'm allowed to multiply those because the inner dimensions of 4 match. And then the result should be the outer dimensions, 3 by 1. 3 rows, 1 column. So it's just a handy thing to sort of keep in mind. Inner dimensions match. Result is the outer dimensions. We'll use that a lot throughout the course to make sure that we're living in the right vector spaces. All right, how would I solve this system? Yeah, RREF. Just set up an augmented matrix and RREF it. So I set up 1, 0, 2, 4, 0, 8, -2, 3, -4, -3, -3, -6. Augment with my zeros. And I would RREF it. So today, finally going to show you how to use technology to do this. All right, so I want to enter this matrix into my calculator and get it to RREF for me. Oh, those all dead. that one works. All right, so your TI has a matrix button. If it's newer, it's a second. It's like second, the inverse button on the left near the top. And if it's older, it's just that button. It's not a second function, but it's the same button. So you hit second, go into your matrix menu. You've got 3 menus: names, math, and edit. Okay. So math is where you give commands like RREF. Edit is where you enter your matrices. And names is where you choose what you want to, like RREF. So cursor over to edit, and we're going to edit matrix A. Okay, so first you have to tell it the dimensions, how many rows, how many columns. So this was 3 rows, 1, 2, 3, 4, 5 columns because we're entering the augmented matrix. So this is 3 by 5, and it builds a 3 by 5 matrix. Now you just have to put in all the entries, and it works across. Each time you hit enter, it goes to the next spot across the row. So I've got 1, 4, -2, -3, 0. Next row, 0, 0, 3, -3, 0, and 2, 8, -4, -6, 0. All right, so now just quit out of this screen. So just hit second quit. Takes you back to the home screen. Go back into the matrix menu and go and cursor over to math. And I think it's option 0. Nope. B, RREF. It's option B. So you scroll down to option B. It's RREF for reduced row echelon form. And so you press enter, and then it comes up in your home screen. It's saying RREF what? What do you want me to RREF? And you have to say matrix A. So you go back into your matrix menu, and in the names menu, choose matrix A. Close your parentheses, hit enter, and it gives you your RREF'd matrix. So after Thursday, sorry, today's Thursday, after Tuesday, when you write out all the steps on an RREF for the quiz, you won't have to do that again. You can use technology to get your row reduced matrices. We'll just write out the solution the way we've been doing it up until today, and then we'll sort of translate it to this new fancy parametric vector form. All right, so this says, if I translate this to equations, it says, I think I'll scroll up a little bit. x1 plus 4x2 minus 5x4 equals 0. And then the next equation says x3 minus x4 equals 0. And the last equation says nothing. It's a row of zeros, right? So what are my pivot variables? What are my basic variables? x1 and x3. Yeah. So the pivot positions are here and here. That's the x1 column and the x3 column. So x2 and x4 are free. Okay. So the first thing I do is in each of those equations, I want to solve for the basic variable in terms of the frees. So I'll do this down here. So x1 is going to be negative 4x2 minus 5x4. Solve for the basic x1 in terms of the frees. The next one is going to be x3 equals x4, and then x2, x4 are free. So I'm going to translate this to parametric vector form. So I'm looking for a solution, x1, x2, x3, x4. Okay. Yes, absolutely, it should. Thank you. Okay, so my solution is are going to be values, x1, x2, x3, and x4. I want to know what those equal. So my solution, this is the vector part of parametric vector form. You're writing the solution as a vector. All right, the parametric part, the word parametric, the base of it is parameter. So your parameters are x2 and x4, your free variables. So you're going to set up a vector for each of your free variables. Those two free variables, or however many you have, become weights. And then you fill in what has to go in the vectors in order to write, in order to have the solution come out. So you want x1 should be something x2 plus something x4, right? So you go look at your solution. X1 is -4x2 plus 5x4. So you put a -4 here and a 5 here. And then x2 is free, right? So whenever you have a free variable, you just use a 1. So it just says like x2 equals x2. So x2 is free, so I put a 1 here and a 0 here. So that way my second entry says x2 equals x2. x2 is free, so it doesn't have anything that controls it. All right, x3 equals x4. So x3 equals 0 x2s, 1 x4. And then x4 is free. So I just want this to say x4 equals x4. So I put a 0 in the x2 vector and a 1 in the x4 vector. So that's my solution written in what's called parametric vector form. Vector because it's a vector of solutions, x1, x2, x3, x4. Parameter or parametric because it uses x2 and x4 as parameters, so things that change. So if I take each of my free variables to be 1, then I can check that I have a particular solution to the system, right? So if x2 and x4 were both 1, my solution, x1, x2, x3, x4, would be -4 plus 5, which is 1. And x2 would just be 1. x3 would be 1. And x4 would be 1. Okay. So x1, x2, x3, x4, all are 1, should be a solution to the original system of equations that I had as my problem, right? So if I come up here, if I put in 1s for all my variables, all 3 of these equations should be true, except they should all be 0s, right? Because I solved the homogeneous system. So if I put in 1s here, I would have 1 plus 4 minus 2 minus 3. That is 0, right? Check. For the next equation, I would have 3 minus 3 is 0. Check. And 2 plus 8 is 10. Minus 4 is 6. Minus 6 is 0. Check. So you can check your work even when you have infinite solutions, right? Even if you write your solutions in parametric vector form, you can get one single solution and check it. Make sure you did everything right. All right, so if I want to describe this set of solutions to the homogeneous system geometrically, so I want to describe this geometrically. Well, where do those solutions live? R what? 4, yeah. So it's some subset of R4, right? Our solutions to that system. So geometrically, your textbook uses the word plane to describe a subset of Rn, right? So if you're in R3 and you have some subset of R3, like that's typically a plane. But then they continue to use the word plane even when you go up dimensions. So like you have this picture of a flat thing of what a plane is, but your book uses the plane in a more general sense to just mean like a subset. So we're going to say that this is a plane and I'm going to put it in quotes because it's not necessarily a two-dimensional thing, but it's a plane in R4. It's going to contain these two vectors and the 0 vector. Because it's all the linear combinations of those two vectors, and that will definitely contain the 0 vector, because if you take x2 and x4 to be 0, you get the 0 vector as one of the linear combinations. So it'll be containing these two vectors, -4, 1, 0, 0, 5, 0, 1, 1, and the origin, 0, 0, 0, 0. So if you could picture R4, you could picture those 3 points and a plane containing them. Oh, whoops. Sorry, that went down there. Okay, so that's it for the demo portion. Let's take 30 minutes or so and work through the activities on the next page.